All right, well, we'll get going here. Thanks for joining everyone to another version of the Tech Tuesday. My name's Todd Olheiser with the Colorado Ready Mix Concrete Association. And a couple things here. As all of our meetings, we'll start with the antitrust statement, which because we have competitors in the meeting, basically means we won't discuss individual pricing or individual customers or things of that nature. If there's any question about that, please stop the meeting at any time. A couple other people just joined online. Let's start with some, we'll end with you if you don't mind. Let's start with some self-introductions in the room here.
Zach Grimes, Mountain Cement.
Jeremy Martin, Mountain Cement.
All right, and I'll have our speaker introduce himself last. So Nigel. Nigel, do you want to just state your name and who you're with?
Can you hear me, Todd?
Yeah, I can now.
Okay. I'm Nigel Noah. I work with Terra CO2. We are a pozzolan producer in Golden, Colorado.
Thanks for joining. Who's the S Lockery? It's working well. Who's the S Lockery? No microphone. All right.
I'm going to man the chat.
Up the man that, yeah, I'm going to do that. Okay, Scott Lockey with WW Clyde. All right. Thanks for joining, Scott. Adam?
Hey there. Yep. Adam Cobble, City of Aurora.
All right. Thanks for joining. Angela.
Hi, my name is Angela Babo. I am an architect with High Plains Engineering and Consulting in Hudson,
All right.
Colorado.
Thanks for joining. Dan.
Yeah, Dan Cornell and work for Full Force by ABC Polymer.
All right. Thank you. James.
This is James Rickey, CDOT.
All right. Jason.
Jason French, Ames Construction.
All right. Mike Callahan. Mike Callahan. Looks like you're muted. Mike Higgins.
Mike Higgins, Pete Lean and Sons.
All right. Steve Heinrich.
Steve Heinrich, Burnco, Colorado.
All right. And Travis.
Travis Davis, Ames Construction.
All right. I'm admitting several others on that just started here.
Todd, it looks like S. Lockey is Scott Lockey with WW Clyde. He doesn't have a microphone.
Right. Okay. Yep. And I just read here Mike Callahan's with Pete Lean and Sons, and I just admitted a few more. That includes Bucky. Want to introduce yourself?
Hey, yeah, sorry, we're out of town, just got logged in, so it's Bucky Brown with Ames, and I got Dustin, another Ames guy with me, so we'll be listening in.
Okay, excellent. Adam, did we already have you introduce yourself?
I believe so. Yep. Adam with City of
All
Aurora.
right. All right, we had some others join late. Who did I miss? Anyone? Okay. Thanks for that. We've got a real diverse group. I see we have a lot of contractors on and so forth, so that is excellent. Just as a note of record, this is being recorded. And so for your listening enjoyment, if you want something to download and, listen on your way home or to put you to sleep tonight, no offense. It'll be available. And by the way, guys, when JT sends his link out again, feel free to push it out there. We've had like 100 downloads or 100 views of this web, some of these Tech Tuesdays. So, I mean, in our world, that's on the verge of viral. It's right up there with Taylor, I'm saying. So anyway, let's go to the next slide if you could. I'm gonna start with a couple slides and I'll have Zach do a formal introduction. But as far as CRMCA memberships, I don't know if all of you are members, but just a couple of things. If you're interested in membership, we represent the industry regarding legislative issues, education such as this, most of the ACI certifications that deal with fresh concrete. Of course, our testing program, the Concrete Testing Adherence Collaboration, which is now in US and Canada, believe it or not, and really gaining strength. So anything we can do collectively is what we're doing. And then regarding the technical committee, feel free to reach out to JT if you would like to be involved in more items on the technical committee. If we could go to the next slide. So regarding Tech Tuesday, we've started this series this year and really seen some great response. And it's things like this that we had been doing in various aspects. Usually one of the three market committees would want, hot weather concreting, cold weather concreting every year, in addition to some of the other things. So we pulled these together and really seen a good success out of these. So thanks for joining Tech Tuesday. I think I have one more slide. Appreciate our sponsorship with Burnco, Full Force, Creso, GCC of America, and Wholesome. So thank you to our sponsors. Really appreciate the participation in regards to this. I believe the next slide is your introduction. Is that right? So regarding this, I'm going to turn it over to Zach. He's going to introduce himself and his employment and so forth. And so you're on.
All right. Well, thanks, Todd. Thank you, everyone, for joining us for this Tech Tuesday. Talk a little about some cold weather concrete. One city's perspective. I would be the city in this instance. A little about me. Zachary Rover. Call me Zach. Born and raised in Indiana, but I got here as soon as I could. I've lived my entire adult life here. Spent over 20 years in the geotech industry. Worked for a few of the major firms around town, around the state. Who will remain unnamed. But some of the bigger projects that I've worked on over the years, a lot of roads and bridges, a lot of infrastructure. I was quite involved.
Trying to get this microphone closer to you. They're having a little bit of trouble hearing.
Okay, I can hold on.
No, just
or I can speak
see
more
if I tip this tape
loudly.
So yeah, if
Fast-paced,
I think you
high-tech
talked
setup
about
here.
this.
All right. Is that any better?
Is that any better, guys?
All right.
Yeah, it's fine.
Okay, good.
Okay,
Good.
thank
Thank
you.
you.
Yeah.
All right. So, as I was saying, been involved in quite a few major road, bridge, infrastructure projects around the state over the years. I was involved quite a bit with the Eagle P3 project, which you may recall, the commuter line, especially the A line and the one that goes up to Ward Road. If you've taken a train out of the 40th and Colorado station or the Peoria station, I tested all that concrete. And then they made me test it again. So a lot of that, the Central Park Bridge was involved in all of that. I spent several months out of town in New Mexico working on a railroad bridge for the Union Pacific. Once upon a time, I worked on the Highway 67 realignment around the Cripple Creek and Victor Mine. That was many moons ago. And then of course, just innumerable drilled piers and sidewalks, PCCP, that sort of thing. So I've been involved with concrete for quite a while. Not an expert by any stretch of the imagination, but I've been around it quite a bit. And so I felt like I could come and speak on the topic of cold weather placement, because that is something we'll be moving into, even though it seems like it may be far, far in the future. What would it be, 90 degrees every day? But it's coming before too long. So, oh, and then of course, now I'm at the City of Aurora, where I operate under the title of Lab Engineer for the Public Works Construction Materials Lab. So I was asked by JT to sort of give a talk really from the perspective of a municipality and the owner, maybe as opposed to a producer or a contractor. And I was trying to come up with an angle, like what specifically would the city's angle be that someone else might not have. But really, I think we're all approaching this, or we should be approaching it from the same angle. We all want a quality product that will perform, that's durable, and that we can get a good value out of, get a good return on investment. I guess the one difference is that the city is not, there's no profit motive for the city, right? We're not trying to make money, so we can be a little more picky in when and where we work, as opposed to, say, production deadlines, not really a thing for us. We can decide to work or not work. We actually do not do a ton of work in the winter time for this very reason, because we want quality, we want performance, we want durability. And so we have the luxury, for lack of a better word, to say, well, we'll put off that big project until the summertime. We'll put off this road work or what, until we have favorable weather conditions. But that's not always the case. If you're out there trying to build a subdivision, if you've got a bridge that has to go in, you've got to work. You don't get to choose when you get to work. You have to work year round. So that's why today we're going to talk about some cold weather concreting. So first of all, what is cold weather? So everyone, of course, has an idea of what cold weather is, when you need to put a sweater on, when you need to turn the heat up or off. But we'll go with ACI 306. For ACI 306, we've got 3 consecutive days of either average daily ambient temps falling before or below 40 degrees. Now, this is in a 24-hour period, right? Take the temp once an hour, average those temps together. If it's average is falling before 40 degrees, 3 consecutive days, that is considered cold weather, and we'll want to employ our cold weather procedures. Also, air temperature does not rise above 50 degrees for more than half a day in any 24-hour period, right? And that's any 24-hour period. If we start placing concrete at 4 o'clock in the morning, then between 4 a.m. and 4 a.m. tomorrow, if the temperature does not rise above 50 degrees for more than 12 hours, then that is cold weather. And we'll once again need to employ our cold weather procedures. So now that we have an idea what we consider cold weather, talk about some challenges to cold weather placement. And this should not be news to anyone who's been working in the industry for any amount of time, but definitely bears repeating. So let's just talk about a few. Frozen ground. This is a big one. For subgrade, frozen subgrade soil, snow, ice, these sort of things. I mean, you're going to encounter them. Maybe not necessarily if you just opened up a hole, but if your project is sitting out there in the weather, in the elements, there's a potential for some freeze, and we obviously don't want to place concrete on frozen ground and we're going to get into more detail in all of these. Rapid temperature changes. This is a big one here in Colorado. We all know, right? The way the weather can change around here. Was it last winter or maybe the winter before? I think it was like 70 degrees at noon and it was like 10 below the next morning. So definitely we have our share of rapid temperature swings here in Colorado. Improper curing. This is now we're talking, curing compounds. We're talking finishing times. We're talking blankets. Blankets. We're going to talk about blankets a lot because blankets are a big deal. Blankets. Cannot get enough blankets. Delayed strength gain, right? As the temperature drops and as the concrete temperature drops, it doesn't hydrate as quickly. It doesn't gain strength quickly. So this is definitely a big deal if, let's say we're doing some emergency repair in the street and we need it to gain strength quickly because we gotta get that road open again. The last thing we need is our slab exposed to the elements, taking its sweet time to gain its strength. And then of course, freezing of concrete, the absolute, worst case scenario. We didn't cure it right. We didn't prep our subgrade right. et cetera, et cetera. Now we have actual water freezing in the concrete, which is, of course, highly detrimental to the finished product. So frozen ground. What's the problem with frozen ground? Well, one, results in uneven curing and cracking due to the temperature differential. If I put in 75-degree mud in the ground and the ground is 25 degrees, once that ground starts to thaw, it's going to take a lot of the heat. That's a lot of my hydration heat out of my concrete. Now the top is going to be warmer than the bottom. It's going to cure faster at the top, right, than it would at the bottom. Also potential for subgrade consolidation or subsidence. This is the big deal. This is really the big deal of placing concrete on on frozen ground, because obviously when that soil melts, when that ice and that soil melts, now that soil is going to collapse, right? Because that ice has a fair amount of volume, much greater than liquid water. So once that soil, it may seem like it's solid, it may seem like it's hard as a rock, but it probably will be hard as a rock. It's got ice in it. So as soon as that concrete hits that soil, starts to melt that subgrade, now your subgrade is going to start to shift. It's going to consolidate. It's not going to hold up. Even if your slab is perfectly placed, beautiful concrete, if your subgrade soil is frozen, you're going to have some issues with some cracking, some subsidence, and just a poor quality product once that subgrade warms up. So rapid temperature changes in proper curing. What do we mean when we say a rapid temperature change? We just talked about it a little bit. I just gave an example, but again, going back to ACI, rapid temperature change will define, generally considered to be a change of more than 20 degrees Fahrenheit within a short period, such as a few hours. It's not specific, 45 minutes or 2.5 hours, but just a few hours in general. And obviously this is, as we're moving into the cold weather again, this is going to be a big thing in the fall, and a lot of times in the spring too, right? It'll be gorgeous in the afternoon, and as soon as that sun goes behind the mountain, temperature drops really quickly. So that is a consideration when we're trying to get work done with our shorter work window that we have in the winter time. And here is this is table 5.1 out of 306, just to give some examples of what they say. If this is the size of your slab, this is the thickness of your slab, these are your ambient temps, this is the maximum temperature change that's allowed to guarantee that you're still going to have, or at least to make it far more likely that you're going to end up with a good product. So again, that's table 5.1. If you want to go over that, peruse it on your own time there, please do. Freezing of concrete. Now we know water expands, right? Water expands up to 9% by volume when it freezes. So what's going to happen to my concrete? Put it down, it takes up this much space, but now that water starts to expand, now the voids in my concrete are going to increase, right? And then when that water finally melts, now I've got voids in my concrete. It's not going to be nearly as strong as it would have been, right? Because we know even with air entrainment, right? We need some air entrainment because of the freeze thaw, because the water expands. We need some space in there. But we also know that, once you reach, I think it's like, once you reach like 8% under air, every percent that you go over is going to reduce your compressive strength by about 500 PSI. And again, because you've got more voids and less aggregate, less cement, right? So once that water freezes, expands the volume of our concrete, and then it thaws, and now we've got all these voids in our concrete that are just going to affect integrity of our slab. So we really want to protect against freezing. And the concrete we can work in cool, we can work in cold, but the concrete itself needs to be maintained so that at the very, very least, we don't freeze, right? And the water in concrete capillaries begin to freeze at about 28 degrees Fahrenheit. Now, why is it not 32 degrees? Well, I suspect it has something to do with the heat, right? The exothermic quality of the cement hydration. So it's making heat in there. So, and pressure, I suppose, too. But now I don't want to get too far out over my skis. Someone who's more of a chemist or a physical sciences guy could probably explain it a little bit better. But this is one we really need to watch out for. And concrete surface can begin to freeze above freezing, whereas the slab might not freeze until it's below 32 degrees. The actual surface can begin to freeze at around 35 degrees Fahrenheit. So really important when we're pouring our slab, and I'm mostly I'm thinking about flat work. It's not as much of an issue clearly when we're pouring into a form. If we're doing piers or grade beams or things of this nature. When you've got a big block of mud, like it's not necessarily going to be so much of an issue. But when we're talking about flat work, PCCP, sidewalks, curb and gutter, etc., where it's going to be exposed until we can get the blankets on it, right? So it's very, very important. We get that mud on the ground, we get out there, we finish it, we get the blankets on it before the sun goes down, so we can reduce the chances that we're going to have frozen surface. Because we know, when the surface is not properly cured, not properly finished, that's where we get spalling, that's where we get degradation of the concrete surface. So it's really, really important that we get that concrete on the ground, get it finished, and get the blankets on it as quickly as we can. And of course, delayed strength, and we mentioned this a little bit. Here's a random chart that I found. Could have been tested done somewhere around here, because I see that's got Platte River aggregate. I'm guessing they crushed it. We don't want to put river rock in our concrete, but that's a different discussion. But strength reduction of up to 50% can occur when the concrete freezes before reaching 500 psi. And it will, here's the thing too, it will be, see, how slowly it will gain strength when it's cold. And then there's our ideal line, there's 70 degrees. End up gaining even faster when it's hot, which might not be the worst thing. But really we don't, again, it goes back to rapid temperature changes. We don't want our warm concrete now to suddenly be cold concrete and then be warm concrete again tomorrow. Although it will take off again. I recall one time I went out to the RTD bus barn out in Boulder. They were doing some work in the bus bay, and they had some high early because they wanted to get the thing back into production. So I went out there, and I think it was in September even, and it was like 90 degrees, 95 degrees that day. And it's a high early mix, right? They want to get the thing open. So I make my cylinders and I put them in a bucket of water, right? So they don't get too hot. Next day, it's like 35 degrees in the morning. And that bucket was sitting outside, cold water, cold cylinders. They wanted a 1-day break. They wanted like a 12-hour break. So I take it back to the lab. I know it might have broken at like 300 psi. I'm just like, oh my God, what did I do? Well, put them in the fog room. They warmed up. The next day, they started making strength. 3 days later, they're right back where they should be. So it's not, if our concrete gets cold, if we let it get away from us a little bit, it's not necessarily the end of the world. It will bounce back, but we want to avoid that sort of thing as much as we can. So, and obviously, if it's going to, lose 50% of its ultimate strength before it's done curing, well then, if we need a 4,500 psi mix and it's never going to make more than 22 or 2,300.
I'm trying to, what's up?
I just have a question.
Yeah, this is not,
Mortar
yeah,
breaks,
yeah,
they are all low.
yeah.
I'm reaching out again to Ben and Sydney to see if they can provide.
There you go. Beautiful. Right. Power. You have the power. Just a little window into someone else's world. We're all out there doing our thing.
At home. Yeah.
All right.
Don't we all?
All right, pardon us, folks. All right, so again, keeping the concrete warm throughout the curing period. It's gonna go a lot. It's gonna go a long way to making sure that we get the product that we intended. So knowing all these problems that we have, all these difficulties with cold weather concrete, what are some mitigation strategies? Basically, I've broken them down in basically 3 different categories. Subgrade prep, talked a little bit about, placement procedures, and then of course, curing and the protection. So we'll start with the subgrade prep. Before we do that, yeah, so what is maybe might have should have put this slide ahead of this one, but anyway, we'll go here. So, oops, pardon my fingers. So this is the chunk out of the City of Aurora 2023 roadway design construction specifications. It's fairly boilerplate. It pretty much mentions all the things we've talked about. Placing below 40 degrees ambient, contractor shall provide satisfactory maintenance means to protect maximum injury and freezing, and so on and so forth. Between 50 and 90, placing concrete should be discontinued by 3 p.m. After the concrete has been placed, provide sufficient protection. And you all can read the blurb, and it's fairly boilerplate. If you look at CDOT spec, if you look at different municipalities, it's all going to be something similar to this, right? It's all cold weather protection, cold weather placement technique. It's going to work. If it works here, it's going to work everywhere. With slight variations of, depending on your the weather. Now, obviously, if we were in Phoenix, we wouldn't be having this discussion. We'd be talking about hot weather concrete. But any place where it gets cold, like it does here, is going to be something like this. You know, it's going to be place between 50 and 90. I think we all know that's pretty standard. We all know that from our ACI Field 1, right? The time of day, and then of course, required strength. All of it is in accordance basically with ACI 306. Well, that's basically what governs placing concrete. So everyone's going to basically be by their specs in accordance with 306. Tweak it here and there, depending on what your local situation is. So again, subgrade prep. This project right here was a project I worked on for the city a few years ago. This is the Tollgate Creek Trail Phase 2. And as you can see, it's a bright sunny day. There are their blankets, right? They came through the day before. They scarified, they moisture conditioned, they recompacted. I mean, I cannot stress how important it is that the subgrade be properly prepared. Again, you could have the most beautiful mud. You can have the most crackerjack crew. You've got ace finishers. You've got your blankets. You've done all that stuff. But if your subgrade is not good, and this goes for anything you're going to build. I mean, if you know, we're not talking asphalt, we're talking concrete, but anything that you're going to put on the ground, where if that subgrade is not properly prepared, it's not going to perform the way it should. Your brakes might come back through the roof. Oh my God, 5,500 PSI at 7 days. This mud is great. Oh, but they didn't pull all the chunks of rock, ice and snow out of the subgrade before they placed it. So guess what? In the summertime, we got cracks everywhere. What happened here? So it's so very important before you build anything. Prepare your subgrade. And again, we're talking cold weather, and I'm obviously focusing quite a bit on flat work. But of course, this all again applies to any sort of concrete structure, whether it's in forms, whether it's I guess we wouldn't say in the ground. Drilled piers is a whole different animal. We're not really worried about that so much. But I guess we kind of do because we don't want our hole to collapse. We don't want ice and mud in the bottom of our drilled pier either. So even in that instance, you still need to clean up your workspace and make sure that your soils and your surrounding environment is properly prepped to accept some concrete. So again, these guys did a really good job. We were really this came out really well. As you can see, they were out there the day before. They cut it to grade, places where they needed to condition, they did. And we got our density testing, everything looked good. They had their blankets on it all night. And then this is, probably 9 or 10 o'clock in the morning. And they probably did 50 or 60 yards. Because again, we had that shorter work window. We don't want to go into the afternoon. By the time by the time we get into that last truck, we need to be pulling blankets. The sun's about to go down. So subgrade prep is just so important. So, different methods of prep. One, you can remove and replace your frozen soils. That's seems like a no-brainer. But if you've got something, if you've got frozen, and everything in the Aurora is clay, and clay has typically got a pretty high moisture content. It likes water, or rather, the water likes the clay. So, frozen soil is quite a problem. Whereas if it's in some places we have sandier soils, it might not be as big a deal because it's easier to thaw out. You might not necessarily need to pull it out and put it back in. You might want to do something like ground heaters. Ground heaters will work. They'll work on anything, but depending on what it is you're going to build and how bad or how good, how suitable or unsuitable the soils are. If it's good material and you can get away with just throwing some heaters out there and keeping the ground, above 32 degrees, preferably warmer. But if you can get away with just throwing the heaters out there, throw some blankets over them, that's great. But if it's say in somewhere near a watershed or in a lower elevation, topography, if you're down someplace where the water has been collecting and there's 3 feet of ice. I mean, there's one project back in the day where all I can remember from it is that they had to get out there with like a D6 and just rip because it was 3-4 feet of ice. So there's ground heaters would not have done a thing when you get there. So again, if you can condition the soil without having to tear it out, heat it up, whatever, that's great. But you might just have to pull it out. So throw some good class 6 in there if you're putting down some curb and gutter or some PCCP or whatever it might be. And then of course blanket it. Once you've got it prepped, throw the blankets on there. And proper blanket placement is also make sure there are enough blankets. All right, we've all been around a while. We've all seen examples of good and bad blanket technique. for lack of a better word. Make sure you have enough blankets, make sure they cover everything, make sure they overlap, make sure they're weighted down enough so they're not flapping in the breeze. So that when we come back out in the morning to see what's up, and there's blankets going everywhere, and there's exposed subgrade, just it's proper use. It's not just enough just to have blankets. And make sure they're in good condition. Make sure they're not all torn up. Make sure the insides aren't coming out every place. It's not going to do us any good if they lose their insulating property. So, but again, blankets, they are like the contractor's best friend. And again, even if you're, let's say you're pouring a wall, you've still got the blanket at the top of your forms. You don't want to be losing heat. You don't want to be exposed to the elements. Obviously, your form is going to help you out some, but blankets, just blankets. They work. That's why we use them everywhere. So subgrade prep, right? Very, very important before we build anything. Make sure that the subgrade is suitable for placement. So we got our subgrade prepped. It looks good. Here we go. Here are the guys again out on the trail. There I am taking my picture. When we're placing the concrete, plan around the weather. Again, this is probably 9 or 10 o'clock in the morning. So we got out there early enough to pick it up where it's, and keep, we got pretty good production on this job. We put a lot of concrete down. This was in December, I believe. We put quite a bit of concrete down in December. But again, we had a shorter work window. We would get out there at, place concrete 9, 10 o'clock, maybe by 2, certainly by 3, the finishers are off of it. The blankets are on it, when we're packing it up for the day.
Zach, we have a question.
Sure.
When would you say it's safe to remove the blankets?
From the subgrade?
Concrete.
From the concrete, from the subgrade, from the subgrade, I would say you leave the blankets on until you're about to pour. Leave them on until, until the guys are standing there with the tools and the truck's rolling up. Then you can pull your blankets off. You can keep that heat in for as long as possible. For the concrete itself, typically we'd want 5 days, 120 hours, something like that. We're not trying to get out on it. This if something like this, which is just a recreational trail, we're not worried about getting it open right away. So we can leave those blankets out there 5 days. Definitely, you'll want to maybe take some extra cylinders when you're testing it and break some early. And of course, they're not. The lab cure is not in the same condition as the field, and we'll talk about field cure systems, cylinders a little bit later. But you definitely, if you're worried about getting it open, if you have time, 5 days, leave it out there for 5 days. If you're really worried about it, take a couple of extra cylinders, like you can do a 1 day break, do a 3 day break, a 5 day break, so whatever you need, depending on how quickly you feel like you need to get it on. But if you're not in a big rush, I would say 5 days.
Is there a certain PSI you would aim for, or on those cylinders under the blanket?
Probably 70%. I would say if you can make 70% in 7 days, you're doing pretty well. A lot of mixes, because I do a lot of breaks every day, and it seems like everyone is really loading them up on the cement. We get cylinders that make strength 7 days quite often. So, if you've got, throw an extra sack of cement in there, it's probably gonna start faster.
That helps our global warming approach.
Yeah, absolutely right. More cement. Yeah, cement production of cement. It is true. It is fairly carbon intensive, right? All that fire we need to make that clinker. So I know that and there'll probably be a talk at some point. This would be better that a producer would speak to this, but I believe that they are working on mixes that don't require quite as much cement.
Yeah.
And of course, that's why we use things like fly ash. That's why we use different pozzolans that don't require all this massive amount of energy to produce, and find alternate sources that will still give us the compressive strength and the durability that we need without burning so much fuel. But certainly, if you throw some more cement in there, it's going to go faster. But if you're really worried about it, if you really need to get it open, I would take some extra cylinders, take some extra, do some extra breaks. And like I said, about 70, we usually rule of thumb, if it makes 70% in 7 days, it's doing pretty well. And again, a lot of the mixes that are coming through the lab are performing much better than that. A lot of them are making strength, making 4,500 PSI at 7 days. Certainly by 28 days, we really don't have a whole lot of 56 day breaks. Everyone does once in a while. Things happen, but yeah. So definitely your QC is going to be a big help in determining when you can uncover when you can actually get out there on it. So inclement weather, obviously, it's going to get colder, it's going to get darker. our work window is going to get shorter here as we move into the winter season. Again, limit work hours to the warmest part of the day. You know, don't get out there at 6 o'clock in the morning and pull the blankets when the concrete truck isn't going to show up until 10 o'clock, because you know you might not do serious damage, but why would you invite trouble? So, and material temps. This is something I solicited some opinions from some of the engineers, some of the inspectors around the city, just to get a rounded perspective. And someone brought up material temps, not just the concrete, right? We batch with hot water, might batch with heated aggregate, or both, depending on the weather. And of course, you know, this not just for ready mix, even though this is CRMCA, but also you think about like grout and mortar. You know, what does the spec say? When it drops to 40 degrees, whatever, you heat the water. If it drops to 20 degrees, heat the water and the sand. You know, so but also things like the rebar. Like, was the rebar sitting out under a pile of snow before the guys tied it in there, right? Because if I've got rebar that's 15 degrees and it's inside of my slab, that's going to cause me some trouble with I'm going to get uneven curing. I'm going to get it's going to suck the heat right out of my concrete. Rebar was definitely the big one, but also it's don't make sure your forms are all icy. The tools that you use and everything, make sure that everything is, if not warm, at least not frozen. So it's not just the soil, it's not just the concrete, but the forms. The rebar, especially if there's a lot of rebar in there. There's typically not a whole lot of rebar in flat work. Cross pans and things that are going to get really heavily used. This obviously does not have any rebar in it. That's not something we had to worry about on this job, but just temps of everything, not just the mud, not just the soil, but the ambient temps and material temps. Not to be a broken record, but I mean, temperature, maintaining things as warm as possible for as long as possible while we're doing the work will ensure that when it finally does cool down, we're in a good place. So, and admixtures, talk a little bit about admixtures. I really don't want to get out over my skis here because I'm not a chemist, but I thought I made a nice graphic. So admixtures are a way that we can help ourselves out when we have a shorter work window, right? Because of the many admixtures, the ones we're concerned about for cold weather, obviously, are the accelerants. And of course, everyone's favorite, calcium chloride. This is tried and true. It's been around forever. It works really, really well. But of course, the drawback to calcium chloride is that it will corrode your rebar, right? That chlorine ion, boy, it really wants that electron. It's gonna do what it can, steal them off that steel, right? And so that's why most places will, in fact, and the city is one of them, we will not allow calcium chloride admixtures in anything that's got steel in it. Just makes sense, right? And that's why you folks that work on CDOT projects know that you need to submit an extra 157 for your epoxy, for your rebar, right? Because even if we're not putting calcium chloride in the mix, road salts, right? Using our road salts, magnesium, mag chloride, and different salts that they use for melting the snow, that's still going to get down into your concrete. Eventually, it's going to find its way down into the rebar, and it's going to start corroding it. So calcium chloride, it works fantastically well, but it doesn't play nice with rebar. So there are others on the market. There are calcium nitrate, similar calcium nitrite. These guys actually, I can't remember it's iron hydroxide. It's sort of like a patina, like copper. Like copper has been exposed to the elements and gets that green patina, and that stops it from corroding. It's sort of the same thing. It actually develops like a little coating on the steel then, which will actually it'll just inhibit corrosion basically. So these are some of the calcium formate is another one out there. And then of course there are some that are based on aluminum that I don't really know too much about, but there's a great ACI bulletin if you're really interested. ACI bulletin, educational bulletin E412, chemical admixtures for concrete. It really goes into the chemistry of it. But just know that calcium chloride works great. Don't use it when there's steel around. There are these other admixtures that are also, I think calcium nitrite might be used as a plasticizer as well. But again, probably a producer could speak to this with more knowledge than I can. But again, if you're really interested, it's a great bulletin. And then goes into real detail about all the different admixtures. So, all right, so we batched our concrete, threw some calcium chloride or not in there to speed up our speed up our hydration. We got it on the ground, we finished it curing. Now, this is not the, I like this picture because it's a nice slab. It's not the best coverage for the curing compound, right? There's obviously a method for application. You want a nice even coat. These guys could do a little better. But curing compounds, making sure, again, making sure it's adequate placement. This is the blurb from the City of Aurora's manual. It's about what sort of a curing compound we want it to be. And this is pretty typical. I mean, just about everything, about every submittal that I see, it's this type of material. This is what curing compounds are made of. So you'll see this in other places too. Again, a lot of specs are very similar. A lot of specs are all based on ACI 306, so they're going to say a lot of the same things. But curing compounds, and then of course, again, coverage. You guys didn't do such a hot job, but it's important to get that curing compound on there. Protect your surface, right? You spend all this time, your finishers are just crackerjacks. They've done such a great job. Don't let it be ruined by improper curing, right? And then again, blankets. You see, this is the same project. You know, we've been out there. It's a little in the afternoon now. We put the slab. It may be the next morning. You can't really tell. But see, these guys did. Look at all those blankets. You know, good coverage. You know, one in the middle is a little bit torn up, but you know, it's the slab is completely covered. You know, they got on it right after they finished it, put the curing compound on, and I can tell that we had very little trouble with concrete on these jobs. And most of the concrete was placed. I wouldn't say most, but if a good portion of it was placed in the wintertime. We had the project started in September, but did various delays, yada, yada, yada. We didn't really get to put a lot of concrete down until like December. And so we placed all through the winter, and we really did not have a whole lot of issues. We didn't have too many little breaks. We didn't have to come back later and pull stones out because these guys were on it. They were good at working in cold weather. They knew their cold weather procedures. In fact, there was a little debate about whether we were going to let them throw some calcium chloride in there because it was getting cold that December. And ultimately we did. We did let them use it because, again, we don't have any rebar on there to worry about. So blankets are a very big deal. Again, I say this over and over and over again. They're going to be your best friend. They're like the easiest things to deploy. You know, contractors should have mountains of them. So once you've got your concrete placed, you know, finished, cured, get your blankets on it. It's all part of the curing process. So that, you know, when we pull the blankets off 3 or 5 days later or whatever, we've got a lovely concrete surface. And quality control. This is, you know, we need somebody out there to make sure that all these things are happening, right? Cure box. Make sure you've got a lamp in there or something to keep it warm. Make sure, you know, don't just set your cylinders in a bucket next to the pour and expect them to be okay. You know, we want to get, obviously, you know, lab cured cylinders are an ideal. You know, they're like the best case scenario. Really, just I look at it as it kind of just proves the mix, right? The supplier sent out a quality product. That's what they're supposed to send. You know, we cured it under the best conditions, and it came out gangbusters. So, but the only way, you know, we're going to get good breaks, you know, is if when they're first cast in the field, you know, the technician is taking good care of them, right? So, cast your cylinders, cure box. Make sure it's insulated. Make sure there's a light in there. Min-max thermometer, you know, keep track of what it's doing. Is it staying warm enough? You know, is it getting too cold? Is it getting too hot? Right? 60 to 80 for the first 24 hours is the spec for your cure box. So make sure that your temps are staying where they need to be. Field cures. We mentioned field cures a little while ago. City of Aurora does not rely on field cure cylinders because they vary too much. They're not dependable. Think about, let's say I've got 60 yards of 6-inch slab out there. It's making some heat, right? It's cooking. The cement's doing its thing. I take these little 4x8s, you know, and I try to stick them under the blanket next to the slab. Well, they're not getting nearly as warm. They're not curing nearly as fast. And also, what happens when, you know, I make my cylinders, I stick them under the blanket, I walk away for the day. Anything could happen. The guys come around, the guys are moving tools around. They kick them, they roll out from underneath the blankets. You know, somebody comes along in the night and takes them. Who knows? I mean, just anything could happen. They're not consistent enough. I mean, we'll make them, you know, if the contractor wants them, but we don't really rely on them. You know, the question about when you're going to pull your blankets. Well, if I take a field cylinder and I break it and it's like real low, you know, I'm not going to rely on that to to tell me when I'm gonna need to pull my blankets off. Might tell me I need to leave them on there a lot longer, more than I even would have if I had better information. But field cure cylinders, they don't. I mean, it's a good idea, and I suppose in an ideal environment, they could, you know, they could do something for you, but the city just doesn't. We don't rely on them. We don't require them. We don't really. Yeah, if you are if say a geotech is breaking field cylinders, we're kind of a little side eye at those. And then we don't, well, how about all that? I worked on. They just end up being trash a lot of the time. Because a lot of times contractors use them as backup. When I was working several years ago on the ILEX project, the I-25 ILEX project down in Pueblo, there were field cures rolling around that job site just everywhere because the contractor wanted to do field cures with the lab cures. But we never ended up doing anything with the lab, with the field cures. They would just, you know, and as the job progressed, they would just be cylinders just everywhere because no one was using them. You know, they were getting what they wanted to know out of the lab cures, which, you know, is the right way to go. But it's just, you know, they end up just being wasted effort, wasted material. They're not reliable. So I'm not saying they don't ever provide some useful information, but the city of Aurora does not rely.
Maybe post tension, something like that.
Could be, yeah. If you can,
Looking for a number.
yeah, exactly. And if you can keep them, you know, if you can cure them properly, so that you know actually cure them in the same environment that the slab that you're trying to stress. Yeah, okay. But there's just too many variables, and so, you know, again, the city just we don't rely on them for anything other than a curiosity. Oh, that's nice. Oh, man, all right, cool. No, it's not. We don't. We just don't rely on them. Maturity meters. We do allow maturity meters, but they're only allowed to estimate strength. We still insist on compressive strength. We want destructive testing. Maturity meters are not, again, they're not super reliable. Not everyone understands how to use them. So we don't tell contractors they can't use them. You can estimate your strength. You know, if you know what you're doing, but ultimately we don't rely on them. We don't rely on them as a. I would never say go ahead and strip the forms based on what the maturity meter says. You know, and that's less of a concern with the city because again we do a lot of flat work. You know, a lot of PCCP, sidewalks, yada yada. But you know, if I'm building a bridge, you know, and I want to know when to pull the false work off of my, I am not going to rely on a maturity meter. You know, I want to have a QC out there. They're going to be pulling lots of cylinders. We're going to be doing lots of brakes. I'm going to rely on that because that's some serious business. You know, you pull your forms and then the concrete's not ready, and then it can be it can be a bad day for everyone involved. So we do allow them, like I say, but they're only for an estimate. Typically, if we're that concerned about it, you know, we'll just use like a high early. If it's something we really want to get open, we'll use a high early or something.
On the maturity meters, have you or has someone done a correlation or comparison of the maturity results versus field results and seen what the percentage is off or similar?
We haven't done a whole lot of that. Basically, when we do use them, you know, we'll cast our cylinders to develop the curve. But then after that, we haven't done a whole lot of AB. I would definitely be interested to see that. We had the fellow, and if JT was here, he could tell me. I can't remember the fellow's name, but he's with you know, I think we're not, you know, at the risk of you know, I'm running to follow the antitrust rules. there's an outfit down in the Springs called Intelligent Concrete, and I cannot remember the man's name, Dr. something.
Beltowitz.
There you go. There you go. Thank you very much. He went off.
Is he?
He went off on maturity meters at the last technical committee meeting because, well, basically, because CDOT took. And here, if you really want to know more, ASTMC 1074. This is the method that governs use of maturity meters. But basically, what, and I should be telling tales out of school, but he was very upset because CDOT took this document, which is 13, 15, 16 pages, or thing, and made it like a 3-page document. Basically said, just whatever, use them. It's fine, just stick them in there, and whatever they say, that's cool. And he went off because he apparently has clients, people he works with, where there's litigation has been involved. Because people have made a bad call based on the information that they got off maturity meters, whether the meters didn't read right, whether whoever was reading didn't understand what they were looking at. But that he can definitely give you an earful about why you shouldn't depend on maturity meters. And again, referencing C-1074, so it'll give you all the information you could possibly stand with regards to how to use maturity meters and how they work. And there also there's some other materials. Tech Tuesday had a presentation on initial curing, and then of course good old ASTM 31, making and curing specimens. You make sure that you get best specimen you can, so that you get the most accurate information that you can, so that you can make the best call that you can. So definitely plenty of literature out there if you want to look into it further. But certainly quality control, I mean, is part of our cold weather procedure. It's part of our hot weather procedure too, but just in general, you need to have someone out there keeping track of what's going on the job, whether it's hot or in this case, whether it's really cold. So I encourage anybody who's interested in learning more, there's some resources for you. And then of course, the last thing, we can talk all about this stuff. Yeah, it's great to know this is the way things should be done, but everyone needs to be on the same page, right? These are the things that need to be discussed at the pre-con. These are things that need to be followed up on at the progress meetings. You know, are we implementing these procedures? Are they working? Are there places where we need to improve? You know, is some of this information not getting out there? You know, if I'm getting if I'm getting low brakes, like, hey, I'm getting low concrete brakes, what's the problem here? You know, oh, I didn't know you're supposed to do this, or, you know, I didn't know you're supposed to put hot water in it when it's this temperature or whatever. You know, it's just like everyone has to be on the same page. It's really critical that it's all well and good to have this information, but if it hasn't been disseminated, if all the guys at toolbox talk aren't on the same page, there's miscommunication, if there's lack of coordination, you know, you can talk all day long about cold weather procedures, but if everyone isn't following them, and if there's not good coordination, you know, something's going to get lost. Something's not going to come out right. Something's going to be pulled out and replaced. You know, something is not going to perform to our satisfaction. So it's important that everyone knows proper procedure and that everyone is on the same page. Again, that's why we have regular meetings. You know, from the project the owner, the project manager, to the producer, to the site super, you know, to the guy out there on the bull float. Like, everyone needs to know what the proper procedures are for working in cold weather. And your project should come out just to be all cake and pie. And that's basically the presentation. So I guess we'll open it up to the chat, or if there are any questions, or if anybody has anything they want to discuss.
There is no questions at this point. Are there some, just want to make one quick announcement. We had a couple other people join us. Looks like, I don't know if I announced it earlier, Thomas Marceau, Tammy Buck, Ross Hamburger, did I miss anyone? Gina Denton, and I think that's it, that joined us a little bit late. I just wanted to acknowledge you guys. Thanks for joining. And here's some follow-up information. We do have time for a couple of questions yet. If there's some questions that anyone wants Zach to answer.
And if anyone has anything to add, if they want to elaborate on anything that we touched on, could be some producers out there. I know there's someone from Burnco on there. If they has anything, you know, you want to add about admixtures, or whether or not you should be throwing extra sacks of cement into your mix, you know. Or,
hey, we got some, throw it in there, man. It's just, we got some cement guys on. Use more cement.
And of course, I'm not an expert. I don't know everything about everything. So if there's something, I mean, if I've missed something or left something out, or if I misspoke on anything, if there's anybody that feels that they, you know, would like to contribute to the discussion, by all means.
It's just good to see blankets and blankets and blankets and blankets, because really that's out of the majority of the times where concrete is exposed, especially when you got flat work for residential and commercial that doesn't have a roof over it, of course, and 12 hours, 24 hours later, some weather event moves in that you're not prepared for. The majority of the time that I go out on to sites with issues, it wasn't blanketed.
It wasn't blanketed. Yeah. It was, they put it on the ground and split. Yeah. Absolutely.
Dan Corno adds NRMCA's CIP 27 is always a good resource for information. as well. So another good resource.
Yeah, absolutely.
And it's even more detrimental now, I would say, with current cements. They
Mhm.
just do not get the heat evolution that they used to get. There's less clinker in there, so there's
Mhm.
gonna be less heat. So it's even more, I think more the case where it's necessary that all these things are followed. So it's good to see, appreciate it.
Yeah, yeah, and that is a good point. We're trying to reduce our carbon footprint. Obviously, production of Portland cement is incredibly energy intensive. So yeah, obviously trying to reduce our footprint, but that's gonna, as you say, it's gonna we're gonna get less heat. So all the more important that we keep the heat in.
Sure.
Yeah, that's a very good point.
Good points. What other questions or comments out there?
This is an informed bunch.
Well, they are, and pretty thorough.
Of course they are.
And I mean, let's face it, it's we've gone through this many a time, but these refreshers is what keeps it right there at the forefront and so forth. So if there's no other questions, I'll wrap this up. I want to say, first of all, thanks to our sponsors. You can see them all there listed. You can see the QR codes and with information on the events upcoming, and then obviously email addresses right there as well. So for more questions and comments, again, when JT will be sending this out, send it out, man. I mean, get this out to everybody that you can think of, especially the contractors. We've got some producers and so forth, and I know we've got some contractors on here, but that's, we want to educate people outside of the, instead of preaching to the choir, we want to get this message out there as far as possible. So, Zach, with that, I want to thank you very much for your attention to detail and your presentation. And with that, we'll sign off and thank you very much for attending, everyone.
Yeah, thank you.
Thanks, Zach. Great presentation.
Thank you, Tammy.
Thank you.
All right, and we'll be on YouTube if you want to see us later.